Welcome back, scholars. It's Thursday, and today we are going over Chapter 2 of our Unit 1 book, Energy Transfers and Transformations. Okay, so in Tuesday's video, we talked about how change is caused by energy. Energy is that ability to cause change, and change is becoming something different. Whether it's physically or something we can see, something we can hear, there's a change. Something is becoming different. And that's all a case of energy acting upon each other. So, in today's video, what we're going to be doing is we're going to be reading through Chapter 2. Moving objects have energy. We know that stationary objects, based on their position, they have energy. Like my bridge back here. If it were to fall off the bookshelf, it would have the energy of gravity pulling it down. So it has potential energy right now. But moving objects, objects that we control, also have energy. So, first thing we need to do is we need to think about this big question. And when we're thinking about this big question, this is, again, 2 to 3 sentences you want to write about. So all throughout today's lesson, you want to think about this big question. Our big question for Chapter 2. How is energy, change, and movement of objects related? Let's read that one more time, okay? How is energy, change, and movements of objects related? So there's 3 things we're looking for. We're looking for the energy. We're looking for the change, the movement of objects. An object is anything, an object. For science, we're using objects that are still inanimate. An inanimate object, such as a water bottle, such as a keyboard, something that is not moving. It stays in one place. We could call plants and animals objects, but I'd rather call them flora and fauna. When I say objects, let's talk about the inanimate, the things that do not have life, the things that cannot move on their own, no matter how many times we have watched Toy Story. Okay? So we're looking for the energy, the change, and movement of objects, and how are they all related? Okay? Before we get too far in, we do have a vocabulary turn. So this is something that in our vocabulary book, our things to know, we want to write down, right? We want to make sure we remember what this is. It's all in one place for us. So, vocabulary, okay? Our term is motion. This is the second thing we're looking for, or the third thing we're looking for. We know about energy. We know about change. Now we want to know about motion. Motion is a noun. The process of an object changing position. So when an object changes position, such as my pen moving from over here to over here, it's in motion. When it stays put, it's not in motion. It's in a position. Okay? So motion, the process of any object changing position from one position to the second position. It's moving. It has motion. Okay? So, Chapter 2. Moving objects have energy. Everywhere you look, you see things move. Riders pedal bikes, people walk and run. Birds fly, fish swim along the bottom of the ocean. Rain falls from the sky. Objects move in deep space too. Planets orbit stars. Meteoroids move through space. Another word for the movement of objects is motion. So anything that is moving is in motion. Remember, this is in big blue words, so that's a vocabulary word. Anytime we see a blue word, vocabulary word. And then we go back to our journal and we think motion, when something changes position, when something is moving. Motion occurs when something changes position. So here in this basketball diagram, we have this arc showing the motion of the ball. It moved positions. It changed positions from being over here, followed this arc into the net, and swoosh. Okay? So think about describing motion. Moving objects are described by how their position is changing. Scientists describe how fast an object is moving and changing position. Scientists can also describe the direction in which an object is moving, left, right, up, down, and so on. So when scientists look at motion, they're thinking, okay, how fast is it going? Usually that's like miles per hour, kilometers per hour, feet per second, or light years. How fast is it going? Or how slow is it going? Okay? It's also, where is it going? It's going up, it's flying, it's going down, it's digging, it's going left, right, north, south, east, west, east. By east, west, you can have that. East by southeast. Thinking about how do we describe that? Because as scientists, we need as much sensory details as possible. The more data you give us, whether it's qualitative or quantitative, and I'll get into that later on, the better off it is, the better I can analyze my data. Okay? Moving on to our next page here. Moving objects can cause changes. So something that is moving or changing positions can cause a change. Okay? Some objects, such as the basketball player in the picture, cause their own motion by moving their muscles. They jump and run from one end of the court to the other. The movement of muscles causes change. Other objects, such as the basketball, are put into motion by outside motion. Okay? Moving basketball players cause the ball to change position. The player's hand dribbles the ball up and down. Players pass and catch the ball across the court. In all of these examples, moving objects are causing change. Here in the picture, the players and the ball in a basketball game are in constant motion, and the motion causes things to change. Well, they gave us several great examples of how motion is in act when somebody is playing basketball, whether they're dribbling, whether they're running, whether they're ducking, dodging, and shooting. It's all motion. What other ways can we show motion? Think about that. What other ways can we show motion? Because at the end of this video, I want you to come up with 5 examples of where we see motion. Where do we see motion? I'm seeing motion myself as I'm recording it into my camera and I'm watching my lips move. That's motion. It's moving. And it's also going to cause change. But we'll think about that later. My hands are always in constant motion as I'm trying to communicate and reach out through the screen to help us further our education. It's motion. Think of 5 more examples of where we can see motion in action. Objects changing position. I think you can think of a few. All right? So, moving on now. Moving objects have energy. Well, there's energy in objects that stay put, like this bridge. It could fall any moment. But things that are moving also have energy. They have the ability to cause change. Okay? So, when a moving basketball hits a net, swish, the net moves. Again, onomatopoeia. Love the word, love the use of it. looking for some of that when we get further into our personal narratives. The net changes from sitting still to moving. When a skier slides down a slope of fresh snow, whoosh! Great onomatopoeia. The snow changes from powdery to hard and packed beneath the skis. When falling raindrops hit the surface of a smooth puddle, splash. The surface of the puddle changes from glassy and still to rippling with motion. Flying basketballs, speeding skiers, falling raindrops, and all other objects have energy. But how can we tell? You can tell because moving objects can cause change, and energy is the ability to cause a change. All moving objects have energy of motion or kinetic energy. So, energy of motion, that's a big phrase. It's bolded, it's in blue, it's got to be a vocabulary term. So when we see one of these vocabulary terms, we want our vocabulary journal and we want to write this down. So let's pay attention here. It's our vocabulary phrase over here. It is energy of motion. It's a noun. An energy of motion is the energy an object possesses while it is moving. The energy an object possesses while it is moving. Another phrase we can use for this is kinetic energy. Kinetic. Anything that's moving has this energy of motion or this kinetic energy. Okay? And they can all cause change. Sometimes it's good, sometimes not so good. Okay? So think back to your 5 examples of motion. Whether it's Mr. Chambers talking and his lips moving, maybe it's his hands talking and moving so fast in front of the screen. Think of your 5 examples of motion and think, how can this motion cause change? It's something that we can observe, something we can see, smell, taste, touch, or hear. How is our motion causing change? How is my lips talking and moving up and down causing change? Well, it's changing the sound. It's producing sound energy, and you can hear and observe the sounds I'm making. It's also changing the air. I'm expelling air as I'm saying this. Might be producing heat energy. It's probably warmer in my mouth than it is out here. I don't know if moving my lips more warms it up anymore or not. Questions to ask and ponder. Okay? My hands moving back and forth, back and forth, back and forth. It's energy. It's changing in motion. It's changing because it's speeding along. It's my muscles, they're contracting and expanding, contracting and expanding. It's change over time. You can hear sometimes, depending on what I'm doing and whether I'm spinning a pen in my hands or I'm snapping, you can hear, you can see that something is changing. My hands are no longer in this place and they're causing different changes. How can those 5 examples of motion you came up with earlier, how can they cause change? My hands can push. My lips can make a noise. How can your 5 samples of motion cause change? All right, moving along now. We've got 3 examples here. We're going to read through these 3 examples, and I want you to think, what do all 3 of these examples have in common? What do all 3 of these examples have in common? So let's read through. 3 more pages to go for this chapter. Let me switch to my pointer instead of my pen. People use the energy of motion so we can harness that kinetic energy, that energy of motion, and use it for good or evil. Because moving objects can cause a change. A moving object can be useful people have figured out many ways to use the energy of objects in motion. We cut our food by slicing it with knives, and we cut our grass with spinning lawnmower blades. These objects in motion can cause the changes that result in getting something done. Imagine trying to push a nail into a block of wood with your hands. That would be nearly impossible to do. Now imagine placing a hammer gently against the head of a nail and pushing the nail into the wood. You still would not move the nail into the wood because it's just there. You hammer pushing, no, you just can't push. So you would still, but if you swing the hammer against the nail of the head, then bang. Okay? If you swing the hammer against the head of the nail, bang, onomatopoeia. But you have to move something in order for it to cause the change. Just its position there, sitting on top, it's not pushing the nail into the wood. You have to swing it. You have to give it that kinetic energy. Okay? The hammer is heavy, and the swing is fast. The moving hammer now has energy of motion, kinetic energy. That energy can change the position of the nail. Energy can change the position, so it could cause motion, even forcing it into the wood. Energy from the moving hammer drives the nail into the wood. But what moves the hammer? What's moving that hammer that we're swinging? Well, the motion of the builder's arm provides the energy of change, the position of the hammer. So humans are delivering that energy. On to our second example of how humans can use moving objects, the energy of motion, kinetic energy, for good or evil. Talking about pendulum clocks. Engineers, such as clockmakers, have applied the energy of motion for centuries. Clockmakers, as early as the 1650s, used their knowledge about the energy of a swinging pendulum to help tell time. Look at the diagram of a clock, shown here. The pendulum on the clock swings back and forth, tick, tock, tick, tock, tick, tock, tick, tock. As the pendulum swings, it causes changes to the positions of the clock's gears. The gears, as a result, rotate the hands of the clock. Those hands point to the numbers around the clock's face, allowing us to tell time. So as the pendulum swings from one end to the other, every time it reaches the farthest point, it hits the gear changes, and the time moves forward a second. Okay? When it swings to the other side on the tock, it hits the gear again and releases to move it another second. Okay? So if you think about swinging motion, such as a pendulum or a swing, the energy of motion of the pendulum arm causes changes in the gears. But what moves the pendulum arm? Gravity. Gravity pulls the arm down as it swings from its highest points on either side. A pendulum clock also has weights or springs that help pull or push on the pendulum. So gravity, that position, the energy of position, when it's at its highest position, it's got more gravity that wants to pull it back down, more stored energy, and it doesn't hold there long, but it releases and swings to the other side, and it swings back and forth, back and forth, back and forth. It's a way in which humans are using energy and motion to help us. Okay? Moving on to our last and final example of how humans use motion and energy to help better our lives. There's plenty of examples. This is the last one I'm going over today. Okay? Wind turbines. Wind is moving air. Whoosh, whoosh, whoosh. Like everything that is in motion, wind has energy. Long ago, people discovered that they can use the motion energy from the wind to cause changes and get things done. People use wind to push the sails of ships to move across the sea. Wind has also long been used to push the sails or blades of windmills. Early windmills captured the wind's motion energy to turn the blades. Then the moving parts inside windmills could, as a result, grind grains or pump water. Modern wind turbines work in much the same way. Wind turbines use the energy from moving air to spin giant blades. The rotating blades move internal parts that produce electricity, another form of energy. So, that's how motion can cause energy and how energy can cause motion. They work one in another. Motion, objects moving and changing position from left to right and right to left and up and down and diagonal and forward. This all needs energy to move, but we can use that moving energy, that energy of motion, kinetic energy, to enact change on other things. So when we go back and back and back to that big question, the big question is, how is energy, change, and movement of objects related? How is our motion related to our energy related to our change related to our motion? How is it all connected? What's the big picture when it comes to scientific phenomenon involving energy? Whether it's sound energy, heat energy, kinetic energy, objects in motion, energy of electricity. Where is this all going and how is it all connected? Think about that, because you got 2 to 3 sentences to answer in today's worksheet about what is the strengths of kinetic, of energy and motion. How is it connected? Motion, energy, change. Change, energy, motion. Motion, energy, change. Change, energy, motion. And with that, I hope you have a wonderful day. I'll see you next Tuesday for our next science video.